What's up everyone, and welcome back to Mathematical Mindset. So right here we have this question that says x raised to the power of 1 over 10 plus x raised to the power of 1 over 15 plus x raised to the power of 1 over 30 is equals to 84, and we are to find the value of x. So guys, the first thing you want to do right here is to simply find the LCM of the powers. Now the LCM of the powers, we have it to be 10, 15 and 30. Alright, so finding the LCM of this, we're going to have the LCM to be 30, and this is how we got the LCM. So from here we have 10, 15 and 30. So we look for the number that's going to go. We have 3. 3 divided 10 is 10, 3 divided 15 is 5, and 3 divided 30 is 10. Now we have 2, 2 into 10, 5, 2 into 5 is 5, and 2 into 10 is 5. So divide by 5, 5 here, 1, 1, 1. So we have the LCM to be 3 times 2 times 5, which is equals 3 times 2, 6, 6 times 5 is 30, and that is how we got the LCM to be 30. Next is to solve for the powers. So we say solving for powers. Now we have the first powers to be 1 over 10. 10 divided 30 is 3, so we know that this can be written as 3 times 1 over 3 times 10, and this is 3 over 30. So we have this, so we go for the second power, which is 1 over 15. And we know that 15 divided 30 is 2, so we have 2 times 1 divides 2 times 15, and this is going to give us 2 over 30. And lastly, we have the last powers to be 1 over 30. 30 divided 30 is 1, so we multiply through by 1, so we have 1 times 1 divide 1 times 30, and this is equals to 1 over 30. So at this point, hence, the expression can be rewritten as x raised to the power of 3 over 30 plus x raised to the power of 2 over 30 plus x raised to the power of 1 over 30, and this is equals to 84. Alright, so at this very moment, we want to simply solve this right here. Now we know that we can easily express x raised 3 over 30 can be expressed as 3 multiply 1 over 30 plus x raised to the power of 2 multiply 1 over 30 plus x raised to the power of 1 over 30, and this is equals to 84. Alright, so applying this property that says if we have a raised to the power of m multiply n, this can be expressed as a raised to the power of n multiply n. Alright, so from here, applying this property, this becomes x raised to the power of 1 over 30 or raised to the power of 3 plus x raised to the power of 1 over 30 or raised to the power of 2 plus x raised to the power of 1 over 30, and this is equals to 84. So right here we're going to say let y be equals to x raised to the power of 1 over 30. So at this point we have this to be y raised to the power of 3 plus y raised to the power of 2 plus y, and this is equal to 84. Alright, so at this point we want to simply rearrange this and set the equation to 0. So by doing that, we have y raised to the power of 3 plus y raised to the power of 2 plus y minus 84, and this is equals to 0. Now you can easily use two methods to solve this. You can apply the rational roots theorem or simply apply this method right here. Alright, now you can watch some of my previous videos to know how you can easily apply the rational roots theorem. But in this tutorial, I'm going to work with this method, alright? But we know that 84 can be expressed as 64 plus 20, right? So this becomes y raised to the power of 3 plus y squared plus y minus into 64 plus 20, and this is equals to 0. But 64 can be expressed in terms of 4 as 4 raised to the power of 3. So we have y raised to the power of 3 plus y raised to the power of 2 plus y minus into 4 raised to the power of 3 plus 20, and this is equals to 0. So open up this bracket, we have y raised to the power of 3 plus y raised to the power of 2 plus y minus multiply 4 raised to the power of 3, we're going to have minus 4 raised to the power of 3, minus times plus is minus 20, and this is equals to 0. So rearranging this, we have y raised to the power of 3 minus 4 raised to the power of 3 plus y squared plus y minus 20, and this is equals to 0. So for this right here, we want to simply apply the difference of cubic formula that says if we have a raised to the power of 3 minus b raised to the power of 3, this is equal to a minus b multiply a squared plus ab plus b squared. Alright, so applying this right here, we have that a is equals to y and b is equals to 4. So right here, we are going to have this to be y minus 4 multiply y square plus y multiply 4 plus 4 square plus y square plus y minus 20, and this is equals to 0. So we have y minus 4 multiply y square plus y multiply 4 is 4y plus 4 square, which is 16, plus y square plus y minus 20, and this is equals to 0. Alright, now for this part right here that says y square plus y minus 20, so multiply y square and negative 20, we have negative 20y square. So right here, you want to think of two numbers that when you multiply them, it's going to give you 20, and when you subtract them, it's going to give you plus y. So we have that number to be 5y minus 4y. When you multiply this number, we're going to have minus 20y squared, and when you subtract them, we are going to have plus y. So wherever we see y, we are going to put 5y minus 4y. So hence, the equation becomes y minus 4 multiply y squared plus 4y plus 16 plus y squared plus y. We're going to put plus 5y minus 4y minus 20, and this is equals to 0. So we have y minus 4 multiply y squared plus 4y plus 16 plus, now factor out this two, we have y to be common, so we have y plus 5 minus, now between 4 and 20 we have 4 to be common, so from here we have y plus 5, and this is equals to 0. So from here we have this to be y minus 4 multiply y squared plus 4y plus 16 plus, now from here we have this to be y plus 5 multiply y minus 4, and this is equals to 0. So at this point we have y minus 4 to be common to this and to this side, so factor out y minus 4. If you factor out y minus 4, we have this to be y minus 4 into, we have y squared plus 4y plus 16 plus y plus 5, and this is equals to 0. So we have y minus 4 multiply y squared plus 4y plus y is going to give us plus 5y plus 16 plus 5 is 21, and this is equals to 0. So from here we have y minus 4 is equals to 0, and y squared plus 5y plus 21 is equals to 0. So at this point we have y is equals to 0 plus 4 and y is equals to 4. So we have the value of y right here. So for this we are going to solve using the quadratic formula. So apply the quadratic formula right here to this. We have that y is equals to minus b plus minus the square root of b squared minus 4ac divided to a, and we have a is equals to 1, b is equals to 5, and c is equals to 21. So y is equals to minus 5 plus minus the square root of b square, which is 5 square, minus 4 multiply 1 multiply 21 divide 2 multiply 1. So y is equals to minus 5 plus minus the square root of 5 square is 25 minus 4 multiply 1 multiply 21 is going to give us 84 divide 2 multiply 1 is 2. So from here we have y is equals to minus 5 plus minus the square root of 25 minus 54 is going to give us minus 59 over 2. So right here guys, you're going to find out that this is less than 0, hence this is invalid. Since it is less than 0, it is invalid, and it's going to give us a complex root. So we want to simply work with the real roots, which is y equals to 4. Alright, so we're going to say for y equals to 4, which is a real root. Now we want to simply recall that at the beginning we said that let y be equal to x raised to the power of 1 over 30 at this point right here. Okay, so we want to simply recall that. So at this point here, we are going to have that y is equals to x raised to the power of 1 over 30. We are working with y equals to 4, so we have x raised to the power of 1 over 30, and this is equals to 4. Next is to simply multiply both sides by 30. So if you multiply the powers by 30, so we have x raised to the power of 1 over 30 multiply 30 is equals to 4 multiplied raised to the power of 30. So this is going to cancel out this, so we have x is equals to 4 raised to the power of 30, and this becomes the value of x. So we have been able to find the value of x. So guys, let's simply verify to show that this x equals to 4 raised to the power of 30 is correct. So we're going to say to verify We have our initial expression to be x raised to the power of 1 over 10 plus x raised to the power of 1 over 15 plus x raised to the power of 1 over 30, and this is equals to 84. And we have that x is equals to 4 raised to the power of 30. So from here we have that x is 4 raised to the power of 30 multiply 1 over 10 plus 4 raised to the power of 30 multiply 1 over 15 plus 4 raised to the power of 30 multiply 1 over 30, and this is equals to 84. 10 year 1, 10 year is 3, so we have 4 raised to the power of 3 plus 15 year 1, 15 into 30 is 2, so we have 4 raised to the power of 2 plus 30 year 1, 30 year 1, we have 4 raised to the power of 1, and this is equals to 84. 4 raised to the power of 3 is 64 plus 4 raised to the power of 2 is 16 plus 4 raised to the power of 1 is 4, and this is equals to 84. So we have 64 plus 16 plus 4 is 20, which is equals to 84. 64 plus 20 will give us 84, which is equals to 84. So from here we have the left hand side to be equal to the right hand side. So we have been able to verify that x is equals to 4 raised to the power of 30. It's a valid solution. So we have been able to verify our answer right here, and we have been able to solve for the value of x in this question right here. So with this guys, I'm going to see you in the next video.